So we're going to look initially at a couple questions that I think these will feel very familiar. Proportional reasoning. So, A, something over 10 is equal to 40 over 50. And you'll be able to just look at that and say, oh, I know what x is just right off the bat. Something over 10 is like 40 over 50. Look. Seems like a nice time to finish. Something like that. 12:41. I can't make too many late jokes today, can I? I suppose that 5 seconds is a little different than 11 minutes, but there we go.
It's not that much.
So x over 10 versus 40 over 50. What would be the unknown? What would make this equal? How do we do this? Or put another way, if these are equal fractions, equivalent fractions, 8 over 10 is 40 over 50, what's the same relationship to 10 as 40 is to 50? Huh. Or if we simplify this fraction to 4/5, what x would make this true here? Maybe some of you are like, well, I don't know, but I know cross multiply divide. 10 times 40 divided by 50, feel free, sure, that's fine. Yeah, but what I notice exactly is it's like, well, to get from here to here is times 5. So whatever this is times 5 is equal to 40. So x is 8. And what I'm saying with this cross multiply divide, that would be x equals 10 times 40 over 50. In Math 10-3, this is probably what you did over and over. Probably did this cross multiply divide for a lot of things. 40 times 50 is 400, divided by 50 is 8. So x ends up being 8. Okay, similarly here. I'm looking for, I guess we'll do B first. I'm looking for this unknown. I noticed that 3/12 is equal to 15 over something. First of all, the look for what kind of is a similar multiple, what I'm looking at is to get from 3 to 15, I probably need to do the same thing to get from 12 to x. So I'm noticing, okay, to get from 3 to 15, that's 5 times bigger. Yeah, exactly, just like the last one. So x should be 60. But if you're like, I didn't see that, I'm not that confident that, I just want something I can do every time, well, you can do this cross multiply divide, which ends up being x is equal to 15 times 12 divided by 3, which was 60. Oh, that's a square. That's definitely not what we're looking for here. Looking for 60. Okay, who's looking at this and saying, oh yeah, I remember this. I've done this. Good. I did pass Math 10-3, and it wasn't just by copying by the smart person next to me. You got to me, that is what I did. Okay, this next one, Now, in general, something that makes math students generally pretty strong is looking for relationships between numbers. Like, how are these things connected? Isaac, Sally, you guys came in late. Now you need your books, right? So let's get to that. Thank you, sir. Good. So I noticed in this case, 25 and 40. Well, there's some multiple. I don't really know what it is, right? It's not like it's a clean multiple. 25 times 2 is 50. There's not just something obvious to get there. Well, what about the relationship between 40 and 200? How many times bigger than 200 is 40? Isn't that also 5? 40 times 5 is 200? So based on what we were talking about earlier, this also needs to be a relationship of times 5. Right? If the fraction is equivalent, both sides are the same, well then 40 to 200 must be the same relationship as 25 to x. So what's 25 times 5? Is that it? X is 125. Or, what we mentioned earlier, we can do this cross multiply and divide. 25 times 200 divided by 40, and this will give us the same thing. X is 25 times 200 over 40. By the way, some of you might recognize, okay, simplify, and I'm left with 25 times 10, 250, divided by 2, 125. Yep, X is 125. Okay. So proportional reasoning, looking at fractions and saying what makes them equal. This is that proportional reasoning. Kind of the first 4 units of Math 10-3 are all this unit conversions and proportional reasoning. So that's what we're looking at here initially. This is going to be a key skill. Okay, next one, similarity. Similarity with polygons. Yes, we just did this in the units 2 units ago. Similarity, we're looking for two things. Shapes are similar. Number one, they have equal angles, which we can't tell you which are the angles. Number two, they have proportional side lengths. Okay, so let's take a look. So that would mean that 42 and 56 are related by the same relationship as 27 over 36, right? Which are related by the same relationship as 60 over 80. Okay. I wonder if that's true. How would we tell if that's true? When we have a fraction, what's a nice way of simplifying a fraction, something more easy to work with? Or maybe put more simply, what does a fraction mean? Doesn't it just mean something divided by something else? So if I put this in my calculator, and let's say I put 60 divided by 80, I would get a decimal called 0.75. Okay? I wonder if that's equal to 27 over 36. Well, it is. That's 0.75. Okay, I'm a little bit less confident in this next one. Let's see. 14, 28, 42, 56. Yeah, that's 0.75 also. Anyone checking, or are you just trusting your teacher? Don't worry, I would never mislead you. Yeah. Never mislead you. Except when I do. But this time I probably wouldn't mislead you. But actually, it's not that I, by the way, can calculate that as easily. What I just did is I simplified all of them. I recognized 42 divided by 14 and 56 divided by 14 ends up being 3 over 4. 27 and 36 both divided by 9 end up being 3 over 4. 60 and 80 both divided by 20 end up being 3 over 4. So they all end up being a similar fraction of 3 over 4. So now that I've proven they're all the same relationship, a relationship of 3/4 of 0.75, yes, similar, because sides are proportional. All sides are proportional. All right. Next one, similar idea. We're thinking about similarity. We're thinking about scale factor and stretch. We're wondering about if this Hot Wheels model car and this actual car, if they're similar, or if the relationship between the sides is the same, then what would be the actual length of the car? Well, this is going to be something that when I set this up, you say, oh, I've done this a million times. But the setup is kind of hard. Okay, how would I figure out this unknown here, the length of this car, based on what I have? This is kind of like a shadow problem, or like a flagpole problem, where I need to figure out, okay, well, the relationship between this to this must be the same as the relationship between this to this. Okay. Or if I said, okay, this one, 2.94 divided by 0.86, that's the stuff in the model car. The relationship between those must be the same as the relationship between x and 55.04. Now, being frank here, I usually like to try to look for some simple multiple that relates them. I don't know what relates 0.86 and 55.04 very easily. Sorry, my mental math isn't that strong. So instead, I'm just going to go cross multiply and divide for x equals 55.04 times 2.94 all divided by 0.86. And that will give me my unknown value, or the length of the actual car. Who's looking at that and saying, okay, yeah, I know what he's doing there. I get that. Okay, good. There's one of you. That means maybe there's some other people that I hope will figure this out. And setting up a proportion, figure out the relationship. So in this case, 55.04 times 2.94, all divided by 0.86. And I get the value 188.16. By the way, this question asks for the nearest hundredth of an inch. I told you guys that with inches, I like to go with fractions because that's what everyone does. But you know what, question asked for nearest hundredth, we do nearest hundredth, even though we recognize that generally inches are like inch, half inch, quarter inch, you know, eighth of an inch, 16th of an inch. You're not going too much more specific than that in general. So this would be something like 188 and an eighth of an inch, somewhere in there. Okay, now, with all that pre-work, we're now going to do a little bit of scale drawing stuff. And just so you guys are aware, you probably won't actually need to use these for this. If you do, I'd be surprised. They're more for the second and third lesson, but it's kind of nice to get away a little bit. I recognize sometimes when a teacher is just yammering and yammering and yammering on forever, not that I would ever do that. When a teacher's blabbering on, it is nice to have something to do with your hand, right? Something to fiddle with. So no problem. Or like to pretend that you're like taking out or something. But right now we're doing more scale drawings. You're thinking through how you represent something bigger or smaller with a representative. And this is an example sort of right here. So it's really unlikely that I can draw an exact, you know, schematic drawing of this car. Probably not drawing it exactly to the size. But I can do it to scale. And what that means is if I'm doing it to scale, I'm kind of shrinking all parts of it by some relationship. So in this case, it's like, this is 1 to 18, or 1 to 24, 1 to 43, or whatever. And how would you describe what that is? How would you describe what a scale drawing is? What would be a good normal person definition of a scale drawing? Either? Can you help us? You're contributing a lot to the class right now, thanks. So, scale model, how can we describe it like normal person language? Oh, trick question. This isn't the best trick question. Well, we might have trick question. This isn't meant to be one. Now, one thing I've seen with vocab is when people say, "What is a scale drawing?" Oh, it's a drawing with a scale. No. Let's use words beyond just what's in there. What are you trying to do with a scale drawing? Did not. Would there be a way to describe it? Maybe should we just say drawing that represents something bigger or smaller? Maybe we should say actually that proportion. That's kind of key, Dave. It's a drawing that proportionally represents. It represents something, but the relationship between sides stays the same. So what might be some real life instances? Well, I can give you a few examples here. One that I've seen a lot is a map. One that I've used relatively regularly is IKEA furniture. Right, you get that little picture of all the pieces. It's saying you got this one. It's not actually showing you the size of it, but it's showing you, something smaller. Maybe we could say like car schematics. Right, you buy the Haynes manual. It shows you that the engine's here, the timing belt is here around the crankshaft. If you need to fix this, you take this piece out. Yeah, great idea. So actually, Isaac, I love that example. We call it a blueprint. And it's a scale drawing if it gives you actually a scale. And like on the blueprint, it'll say, this is the house at 1 to 25 or something like that. And it's basically saying each thing just needs to be blown up 25 times or whatever. It's a great one. So house blueprint. And then you can probably think of some other examples here. This is actually something we run into quite regularly. Would be a schematic drawing or a scale drawing. Now, in general, with these, the scale statement, or we'll just see like a scale factor. These are saying size of the model compared to the size of the real object, and this order does sort of matter. So, first is the scale of the model or drawing, and second is the real object. Or on top is the model, on the bottom is the real object. So, scale statements will be written like this. Basically, if it's a 1 to 2 scale statement, it's saying that for every 1 that the model is, it's 2 in real life, right? It's saying the model is 1/2 the size of the real thing. So let's say there's a model ship kit, and it's marked with a scale statement of 1 to 350. This is saying that the model is 350 times smaller than the actual ship is. And that order I find sometimes kind of messes with us. I actually kind of find it hard to remember which way this goes. So I found that I kind of need to like star this, remember its model compared to the real object. And then I should point out, you can have a model that's smaller, but let's say instead I was trying to do a drawing of like a cell. Well, that's certainly then my scale is going to be much bigger than the actual cell is. So then in that case, the model is bigger. So it's not always 1 to 350. It could be the opposite way, right? It could be that the model is bigger, but more often it would be a reduction. So it could be reduction, and it could be an enlargement. So first of all, a model ship kit, is that bigger or smaller than yours? Smaller. Okay, so that's a reduction. So you know what this photograph going from a 3x5 up to a 6x10? Enlargements. I have found in my experience teaching, when I ask people to do reduction or enlargement, I very quickly get either R or E. Fine, whatever. You lazy, no problem. Okay, a blueprint of a factory. Is the blueprint an enlargement or reduction? Yeah, if you have an enlargement for a blueprint, it's going to be really, really big. Probably not helpful. Okay, how about a scale factor of 50 or 15 to 1? Well, that's then an enlargement. 1 to 50 as a reduction. 3 to 1 is an enlargement. Cool. Smaller, bigger, smaller, bigger, smaller, bigger. Anyone need to move over there?
I was hoping to.
Wow.
There you are, buddy.
Wow. Yeah, sure. So Philip was asked to make these stereo speakers. He got this scale drawing. Got this scale drawing. And we're asked how big this thing will be. How big this thing will be to the nearest 1/10 of a centimeter. Okay, wait, this is a little tricky. I shouldn't measure it on mine because it won't be the same as yours. So let's label this right now. I'm going to just measure Ethan's for you guys. So on the bottom of the front view, it is 2.1 centimeters. Okay, on the top, the height is 5.5 centimeters. And the side view is, we'll say 3.3 centimeters. Now, I think this question is a little bit vague. It asks how big to the nearest centimeter. You could be asked volume, but all it's really asking is for length. So why don't we say we'll just pick a length and go with it. Pick one of the lengths. I'm going to do how big is it in terms of height. That seems like kind of an interesting question here. Although I'll warn you, on your exam, it seems very possible that you may at some point be given 3 dimensions of a rectangular prism and asked what the 3 sides are. So then you would do the scale factors each of them. But you notice here, this is a scale of 1 to 14. 1 to 14. So how would I figure out the actual height of this speaker? Well, I'd go 5.5 centimeters. And I would multiply it by my scale factor, which is 14.
How is it wider on the side than it is on the side?
Oh, this is good question. This is the height. Height is 5.5. Oh yeah, no, I see what you're saying. Yeah, that is kind of weird, eh? Usually you'd think it would be wider front than the yeah, I agree. Yeah. Yes, it's a bit prolonged. Although this does look like that's the case. It looks like it's a skinny speaker.
Yeah.
Probably not like the main sub, that's for sure. 5.5 times 14. So that is 77 centimeters tall. And if I wanted to find also the front view and the side view, well, they'd be 2.1 times 14. So the front view would end up being 29.4 centimeters, and the side view would be 3.3 times 14, which is 46.2 centimeters. Right, so the dimensions would be 77 by 29.4 by 46.2, and if you wanted volume, you'd multiply those together. So maybe I'll even say that. It is a 77 cm by 29.4 cm by 46.2 cm. That's the three dimensions. It wasn't clear which one we wanted, so we'll just do all three. Okay, now this is a little clearer. I like this question a little more. Antonio is 180 centimeters tall. Okay, in real life, he's this tall. In the photograph, he measures to be 0.7 centimeters. And the height of the truck is 2.5 centimeters. That's the photo. It wants to know the height of the truck to the nearest tenth of a meter. Okay. So we weren't given the scale factor. Maybe we can find it. But I think we have a proportion here, right? His height, and then we have his height in the picture, and then we have the truck's height. Okay. So I know the relationship would be between, the photograph, he's 180 centimeters in real life. But in the photograph, he's 0.7 centimeters. And the truck, in real life, we don't know, but in the photo, it's 2.5 centimeters. And some of you are probably looking and saying, hey, wait, why didn't he go photograph compared to photograph, real life compared to real life? Sometimes we go like the same thing compared to the same thing, and then the other thing compared to the other thing. Sometimes we go like the same medium compared to the same medium. So in this case, I went with Antonio over Antonio, and truck over truck, but it could have been picture compared to picture and real life compared to real life. Either would be fine as long as you're kind of keeping the one to one. So in this case, it ended up being top over bottom was real over photo. Although I guess I should note, if we were trying to find the scale factor, which we're not here, I would then need to flip it because you want the actual as the bottom of the second scale. Okay, but to find x equals cross multiply divide 2.5 times 180 divided by 0.7. End up with 642.85. And I notice, wait, I'm not quite done yet. It asks me nearest tenth of a meter, 100 centimeters in a meter. So I need to move that decimal over 2. So this ends up being 6.4 meters. Cool. 6.4 meters. Nice. Okay, so that was a situation where we're given like one of the measurements in the real life, we're given two of the measurements in the picture, and now we have to use that to find out the equals. The other option is we're given the scale factor instead. So ping pong table measures 2.7 meters by 1.5 meters, and I'm just going to initially list these in centimeters because I'm not going to be drawing them in meters. So this is 2.7 meters. How many centimeters is that? Well, if I move the decimal over 2, that's 270 centimeters. 1.5 meters, that's 150 centimeters. Okay. And it asks for a scale factor of 1 to 50. Now, I've kind of debated with how to teach this with different classes. Sometimes we would set a proportion every time, but you guys are kind of a smart group, so I want to just suggest something to you. Okay, you guys are intuitive on the whole. Who thinks of looking at this? We're going from the real table compared to the scale drawing. All we need to think through is it getting bigger or getting smaller to make a decision? In this case, is it getting bigger or smaller? Bigger. So that we have the table, we're making a drawing. Should the drawing be smaller or bigger than the table? The table better be bigger than the drawing. The drawing better be smaller. Okay. So if the drawing is smaller than the table, sure. The drawing is smaller than the table, then that 50, we need to decide whether to multiply or divide. Are we taking these numbers and multiplying them, or are we taking the numbers and dividing them?
Yes.
Yes, awesome. Hey, I gave you, I just asked a yes or no question, and Josh still didn't answer. Maybe I should have been more clear, hey? Which one should we do?
Yes.
I don't think you can answer yes to that, can you? I don't think that's a yes or no question anymore. Oh yeah, you can answer yes to that. Okay, so in this case, let's see, 270 centimeters. So first of all, the 270. If I multiply by 50, I'm going to have something that's 100 meters. 100 meters. My drawing will be like from here to the office. That seems pretty big. I probably can't draw something that big. I probably need to divide by 50.
But you're just not trying hard enough.
That's true, I'm not trying hard enough. I'm sorry, I'm not committed enough. I haven't found a paper that will allow me to draw that.
It's called you just put paper on a treadmill, let the paper go all the way around,
That sounds like volunteering. We're excited to see this.
Oh, no, I'm not.
So, 270 divided by 50, right? The drawing needs to be smaller than the actual ping pong table. So 270 divided by 50, that ends up being 5.4. And then, let's see, similarly, we have 150 centimeters divided by 50, and that ends up being exactly 3 centimeters. Okay, so my sides are going to be 5.4 centimeters by 3 centimeters. I was asked to draw a scale drawing, so let's see here. I'm going to do a perfect scale drawing. Wow, are you impressing me? And this is 5.4 cm. The big thing is we recognize this is 50 times smaller than the last one. Yes, you could have left it in meters. Your answers would have been 0.054 meters and 0.03 meters. But I always feel like use the better units if you can. Okay, next, ratio of the mass of an elephant's brain to its body mass is 1 to 600. Wait. Before we do this, let's think again. This is the relationship between brain to body. And Isaac, you're just mentioning how, you're so ready, you know all of this, you're feeling totally into it. Yeah?
Isaac's a liar, and you shouldn't listen to him.
He also didn't say that, I'm just putting him on the spot. Okay, so, Isaac, help me out. Is the brain or the body bigger? I hope so. Nice, thank you. Bing, bing, bing.
Well, there are people whose brains are bigger than their body.
Yeah.
Wow, interesting. I don't know about that.
That's the thing.
It is assumption.
Yeah. Okay, so this is saying then the brain mass of this elephant, the nearest tenth. So rather than worrying too much about setting up a fancy proportion, Isaac has just pointed out that in the elephant's case, the body is bigger than the brain. I agree. We see this relationship as 600 times bigger. The body is 600 times bigger than the brain, which, by the way, with a human, that's not really, right? Our head is nowhere near 600 times smaller, our brain. We have an unusually large head and brain. Okay, but let's think of it. So it's saying the body, the whole thing is 1650. So 1,650 kilograms. Should we be multiplying or dividing that by 600?
Yeah.
Maybe help me decide on this time. Anyone feel confident? Multiply, divide?
Multiplying.
We're going to multiply this by 600? That's going to be a really big brain.
Such a big brain, yeah.
Right? Sometimes we look and we're like, wait, this doesn't make sense. That's going to be the biggest brain ever. This doesn't make any sense.
Nothing by 600.
Right, so we better divide that.
600 times 5.
Better divide that.
You don't even have 5 brain cells.
1650 divided by 600. And we end up with how big is the brain? Well, it's 2.75 kg. Oh, but it asks here is 10th. So we'll say 2.8 kilograms. So its brain is 2.8 kilograms. Yes, you can set up a proportion. And yes, that's fine. That is actually how I used to teach this set of proportion. But it seems like with one like this, most of you can just multiply or divide. If it's getting bigger, multiply. If it's getting smaller, divide it, right? You probably don't need to be quite so fancy. Okay. Now we've got one more here that I want to look at with you. So you notice on here, on this Google map, we have this 20 kilometer mark. 20 kilometer mark. Now, it's asking us to use this scale statement to estimate the distance. Now, one thing you can do is you can measure it, right? You can take your ruler and you can measure, okay, here is this measurement. It looks like it's 0.7 kilometers. And then you can measure from here to here. It looks like it's about 7 centimeters. So 0.7 centimeters is this. Right, and this is about 7 centimeters, approximately. And this is a pretty good way to estimate. By the way, how do those two numbers relate? 0.7 and 7? How many times bigger? 0.7 times what? Huh. I wonder. How many 0.7s in 7? Probably about 10. With the decimal. Yeah. So what you reckon is, okay, that's about 10 times bigger. But I bet you that if some of you guys were left to this and it was high stakes, you were told you will be killed if you don't have an answer. Yes, I do have a loaded gun here. I'm sorry.
What?
Very high stakes class.
Oh,
Yeah.
well,
So Isaac,
I'm gonna be
let's just imagine this. So you're done for if you can't answer this. But it's okay if you're not precise. I just want to figure out how you'd be able to answer this. First, probably be on the correct page. Good. So he's being held up at gunpoint. This is very violent.
So are you.
Let's think about this. Oh yeah, I guess I was the issue there, wasn't I? It's me. I'm the problem. It's me.
It's true, you are.
So I would bet a lot of you guys, if you were kind of stuck with this, you'd probably say, okay, this is about this big, and there's 1, 2, 3. Oh, sorry. 1, 2, 3, 4, 5, 6, 7. Oh, that's interesting. Sorry. Okay, when I did, I got about 9. Right? But if I knew there was like 8 or 9 of those, what would I do then? What would I do with that? It's like there's 8 or 9 of those, maybe 10 of those, and I know each one is 20 kilometers. Let's go, well, there are 10 of these things. They're 20 kilometers each, and we're going to go times 10 of those distances. I'm guessing it's about 200 kilometers, and in this case, I was asked to estimate. I wasn't told to know exactly how far. I know the relationship is about 10 to 1. There are 20 of those. I think that's actually fine. It's about 200 kilometers. Some of you may have been slightly more or slightly less accurate. I think the measurement was actually 6.8 centimeters, right? So it should be probably slightly less than that. But we're somewhere in this range. Okay, now, if I'm driving this distance, let's go back in this course a minute. If I'm driving 110 kilometers an hour, how long would it take me to get there? Well, in this case, I'm going 200 kilometers, and I need to figure out that at 110 kilometers per hour. How long would that take me? 200 divided by 110 gives me 1.8 hours. Something like that. Okay, I see that I have clearly lost time. I think it's probably time for us to let you start working. Pardon me? Yeah, sure. Now, for this next little bit, I was thinking I'd crush through and get into our second lesson today. That's not happening, obviously. What I'd like you to do this practice. This is one where you just got to try, see how it goes. I think there might be some consternation, sadness, and tears, but I suspect actually going through you perfectly fine here. While you're doing this, I would like you guys to make your way up toward my desk at some point so that I can go over the thing for career day with you. I will pull up the careers up here and I'll be kind of slowly scrolling through them. If you see something that appeals to you or you already know something you're interested in using for it, just come up and let me know and I'll put you down on the thing, okay? Everyone will need to have a career day picked out for our career day thing next Thursday. Cool? All right, great.